Ever wonder how numbers are classified in mathematics? Today, we dive into that very question. Mathematics is a vast field, and the foundation of this expansive universe is built on a simple yet intricate concept: number sets. These sets are like the different families in the world of numbers, each with its unique characteristics and members. Our journey today will cover a variety of these sets, from the natural numbers which we use for counting, to the integers that introduce us to their negative counterparts and the neutral zero. We'll explore the rational and irrational numbers, the difference between them, and their place in the real numbers set. We'll delve into the complex numbers, where the real meets the imaginary, and the exclusive club of prime numbers. We'll also look at the classification of even and odd numbers, the fractional numbers representing parts of a whole, and the intriguing concept of imaginary numbers. Stay tuned as we embark on this numerical journey. First off, we have natural numbers. These are the positive integers we use to count objects. Think about it like this. If you were to count the number of books on a shelf or the number of apples in a basket, you'd start from 1, right? That's where natural numbers start, from 1, and they extend indefinitely. From 1, 2, 3 onwards to infinity, these numbers form the heart of our counting system. They're the foundation that we build upon to understand more complex numerical concepts. You see, without them, we wouldn't be able to quantify or measure anything in the world around us. They're the starting point of our understanding of numbers and mathematics. So when we talk about natural numbers, we're talking about the very basics, the foundation of all counting. So in essence, natural numbers are the basics of counting. Now let's move on to integers. If you recall, natural numbers are like the first step on our numerical journey. But what if we need to take a step back, or even decide to stand still? This is where integers come in. Integers are a set of numbers that include all natural numbers, their opposites, the negative numbers and the neutral zero. In other words, integers can be positive, negative, or zero. Imagine you're on a number line. Natural numbers take you on a journey to the right, increasing as you go. But integers let you roam freely to the left, right, or stay in the middle. Negative integers represent values less than 0, like owing someone $5, or the temperature dropping below freezing. On the other hand, 0 is that neutral point, neither positive nor negative. So, integers give us a broader scope than natural numbers, allowing us to express more than just quantities. Integers, therefore, cover both the negatives, the positives, and the neutral zero. Next up, we have rational and irrational numbers. This is where things start to get a bit more intriguing. Rational numbers, you see, are those that can be neatly expressed as fractions. Simply put, if you can take two integers, let's say 7 and 3, and express one as a fraction of the other, like 7/3 or 3/7, then you're dealing with a rational number. But what about those numbers that refuse to play by the rules? Those are our irrational numbers. These numbers are a bit more rebellious. They can't be expressed as exact fractions. Instead, they have infinite, non-repeating decimal expansions. A classic example is the square root of 2. When you start to calculate it, you'll find that the decimals just keep going without repeating a pattern. Rational or irrational numbers can be fascinating, can't they? Moving forward, we come to real and complex numbers. The real numbers are a vast set that encompasses all rational and irrational numbers. This means it includes those numbers that can be expressed as fractions, as well as those that can't be, like the square root of 2 with its infinite non-repeating decimal expansion. Real numbers fill the number line, providing a value for every point. Switching gears, we delve into the world of complex numbers. These are numbers of the form a plus by, where a and b are real numbers and I is the imaginary unit. When you think of I, imagine it as a kind of mathematical ghost, a value that can't be pinned down in the real world but is essential in the realm of complex mathematics. Complex numbers are fundamental in fields such as electrical engineering and quantum physics. Real or complex numbers form the backbone of many mathematical concepts. Now let's delve into prime, even, and odd numbers. In the world of numbers, some stand out for their unique characteristics. Take prime numbers, for instance. These are natural numbers greater than 1 that have only two distinct positive divisors, 1 and the number itself. 2, 3, 5, 7. These are all prime examples of prime numbers. They are like the rock stars of the number world, standing alone with their unique trait of indivisibility. On the other hand, we have the even and odd numbers, the yin and yang of integers. Even numbers are those that can be neatly divided by 2, leaving no remainder, like 4, 6, or 8. Odd numbers, however, when divided by 2, leave us with a remainder of 1. Think of numbers like 3, 5, or 7. prime, even, or odd, these numbers keep the world of mathematics spinning. Last but not least, we have fractional and imaginary numbers. Let's dive into the captivating world of fractional numbers first. These numbers represent parts of a whole. Think of a pie sliced into 4 equal pieces. If you take one slice, you've taken 1/4 of the pie. That's a fractional number in action. Now let's turn our attention to imaginary numbers. These numbers might sound like something out of a fantasy novel, but they're very real in the world of mathematics. Imaginary numbers are in the form bi, where b is a real number and I is the imaginary unit. They are used extensively in algebra and complex calculus, opening up new dimensions in mathematical problem solving. Whether it's the practicality of fractional numbers in everyday life, or the abstract nature of imaginary numbers in advanced mathematics, numbers in all their forms never fail to amaze us. Fractional or imaginary, numbers never cease to intrigue us. So that brings us to the end of our numerical journey. We began our expedition with the natural numbers, the first friends we made in our mathematical childhood. They're the positive integers we use for counting, starting from 1 and extending indefinitely. Then we met the integers, a larger set that includes all natural numbers, their opposites, and the neutral 0. They taught us that numbers can be less than 0, and that 0 itself holds infinite possibilities. We ventured further into the realm of rational numbers, those that can be expressed as fractions where the numerator and denominator are integers. They showed us that numbers can be parts of a whole. We also encountered the elusive irrational numbers, those that cannot be expressed as exact fractions and have infinite non-repeating decimal expansions. The square root of 2 was a fine example of their kind. In the kingdom of real numbers, we found a set that includes all rational and irrational numbers, filling the entire number line. They made us realize the continuity of numbers. We journeyed to the complex plane where we met complex numbers, in the form a plus bi, where a and b are real numbers, and I is the imaginary unit. They opened our minds to the idea of dimensions beyond the real number line. The prime numbers, greater than 1 and divisible only by 1 in themselves, showed us how numbers can be unique and special. We also learned about even and odd numbers, a simple yet fundamental classification of integers based on their divisibility by 2. We explored fractional numbers, exemplifying parts of a whole, and we dabbled in the mysterious world of imaginary numbers used in algebra and complex calculus. In this journey through the various numerical sets, we've seen how each type of number, with its unique properties, contributes to the grand tapestry of mathematics. Remember, every number, no matter its type, plays a crucial role in the enchanting world of mathematics.